Hey everybody, this is Larry. This is day 19th of the February of Leetcode challenge. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this problem, other problems, anything in life. I don't know. Life is weird and hard, so anytime you need support. Okay, so today's problem is minimum remove to make valid parentheses. So yeah, I usually stop these live, so if it takes a little bit longer, just feel free to fast forward or watch it on 2x or whatever. Do whatever you need to do. Okay, so given parens, you're trying to remove parens such that is valid and return any valid string. Okay, what does that mean? Minimum remove, it should be minimum removal, right? No, that's just a little bit grammatically incorrect. Okay, that's a little tricky. I mean, my intuition is that I think it's a little bit cheating depending on if you're an interview, because my first inclination, to be honest, is some sort of dynamic programming. But then I took a look at the n, and n is 10 to the 5th. And seeing this n means that there's probably going to be an O of n solution. So there's going to be an O of n solution. And the other thing that once you know that it's probably going to be O of n or maybe O of n log n, but in this case, when you have to look at parentheses and matching, the other thing that would come into my mind, if it wasn't dynamic programming, is going to be stack related things, and stack related things is going to be O of n. So that's kind of my guess, and then we can figure that out from there. And of course, I think this is one thing that's a little bit important, is that the reason why my first inclination is dynamic programming is because I don't have to prove anything, right? The reason why it's dynamic programming and I don't have to prove anything is because the way to do it with dynamic programming is in a way brute force trying every possibility. And when you try every possibility, you don't have to prove anything, as long as you can prove that the transitions are exhaustive, maybe depending on the case, then you don't have to prove it. Where for stack or linear type solution, it's going to be a little bit greedy, and the greedier is going to be a little bit, you're going to have to convince yourself a little bit that is correct, or maybe you won't convince a lot. So that's why that's my first inclination. So with string, with kind of parenthesis matching, a lot of the time it's going to be stack, and that's just from experience. It might not even be right, to be honest, but that's my inclination after dynamic programming. Okay, so I think using greedy works, and then the question is, how do we get rid of it? I mean, I think this is pretty straightforward, actually, now that I think about it. I think the other thing that I also was going to point out is that I think one thing that I do like about doing these explore, the daily problems and explore, is that it hides the difficulty, right? And I think one thing that it's also maybe meta hint, maybe a little bit cheating, not cheating, but just like a little bit of a hint, right? Is that, if you see this in Leetcode, the Leetcode contest, or just Leetcode difficulty, or if you see this on even Codeforce, where they have diff 2 ABCD, and they'll probably rank this as a lower difficulty. Well, if they do, then they hide, it's a little bit of a hint that it's going to be not tricky algorithm, right? Because you're not, like, if this was a easy, you're probably not thinking about, I don't know, segment tree, for example, or something like that, right? So that's a little bit of hint, and that's why I like this explore, the daily explore things, because it doesn't give me a hint with respect to how difficult a problem might be. So you have to kind of force to really try to understand it a little bit. Okay, cool. So I think, I don't know that, I think if you're really slick about it, you can do it live. But I remember there was a time, I don't know if it's this particular problem, but maybe it's a similar problem, where I spent way too long trying to do this live. And by live, I mean that, we construct a string on the stack, and then try to think, and then on one pass, right? But I think afterwards, I remember, and this is just from learning, and I spent a lot of time, right? Is that just, we can keep track of each character. We can keep track of whether it is used or whether the parentheses are matched, and for every unmatched parentheses, we just do one more pass to get rid of it at the end. So that's basically what I'm going to do here, and then it just becomes a much simpler problem where you just ignore the rest of the non-parentheses characters, and then we go through just to pretend you go through all the parentheses one character at a time, and then you have two cases basically, right? You have either, you have stuff like this extra, which I think is in one of the cases. Yeah, I mean, even in this case, but even also here, then in this case, you just remove it, right? That's trivially done. So you mark this as false. And then the other cases, if you have oops, in auto parens, like you have these open parens, but they're not matched. So if they're not matched, that means that, so okay, this can happen at any index. That means we have a negative stack depth or something like that. Here is at the very end we have extra parens. So in these cases we can then mark them as unused, and that's and then we do one more pass. That's basically the idea, and that's how I'm going to finally get started after so much talking. Cool. So yeah, let's start with stack, and then for index, C for character, and enumerate S. So instead of pushing, so how am I thinking about this? Right, stack is going to be contains lower how do I want to say? The index C's of left of, I guess, just left parens, which is this autocomplete, right? And then maybe we have another one that's just bad is equal to set, so that we just bad keeps track of indices we want to remove later, right? Something like that. And then now we can do, yeah. And then now we just simulate the stack. This is, I think I'm definitely hand waving a little bit about this part because this is actually very fundamental. So definitely practice it. It's about kind of keeping, using a stack to keep track of how to make, to keep track of parens in general. So this is going to be very basic. I'm not going to go over it that deeply because I think, you have to either review it or just play around with it until you get it, because this is pretty fundamental. And I'm, I don't know how to explain it other than to go through every enumeration of cases, which is maybe not that interesting. But yeah. And then now for each character, if C is equal to an open paren, then we push it on the stack. We push the index on the stack. Else, if C is equal to close paren, then we check if the length of stack is greater than 0. Then we pop it, right? We pop from the end. Else, we want to add this index to bad, because that means that, this is not good. And of course, you can also use a Boolean array. I don't think it matters that much. Maybe you could do some arguments about spaces. It actually doesn't matter. I just like to do it this way, maybe. And then at the very end, for leftover maybe in stack bad dot add leftover, and then now at the very end we can just return, we join the character for index C in enumerate S if index not in bad, right? Or something like that. And I think that there we go. Maybe. Yeah. Let's of course test some cases. I'll explain this. So basically, I wrote in one line because it makes sense for me. But basically, we're just saying for each character, so we go through the second pass of the string. For each character, if the index is not in this bat that we keep track of, then we return a character, and then that, for all those characters, we join them back into a string. So that's basically the idea there. Yeah. So I'm just putting in the test cases. If only they have a button for this, which they still haven't. This looks good, so I think I'm gonna submit. And I don't think it maybe these are my only cases, or maybe not only ones, but the only reasonable variations that I could think of. Invalid link with S. Oh, okay, so it has to be at least one character, so that's good. This still looks good, so let's give it a submit. Yep, cool. Yeah, so what is the complexity of this? Well, we do 2 loops across the string, so that's going to be O of n. And, you know, in terms of space, the stack is going to be O of n. Bad could be O of n, so it's linear time, linear space. Yeah, and you can... I don't think you could do better than linear space because we have a stack. I don't know if there's an online... I said live earlier, but I meant online algorithm. I don't know that there's an online version of this, but even if there's an online, there probably is O of n if you have to keep track of previous states. Yeah, that's all I have. Let's take a look at the hint to see what the hints are at. Each prefix has a number of overruns. Oh, okay. I mean, I guess so. I don't know if that's faster though. Okay, cool. Oh, yeah, that's all I have for this problem. Let me know what you think. Hit the like button, hit the subscribe button, join me on Discord again. You have a good day. Take care of yourself, take care of others, to good health, to good mental health, and I will see you tomorrow. Bye-bye.